Welcome back everyone. Today we're going to be talking about my TEC calculator. Essentially what it is a means of estimating the performance you'll get with different TECs, with different loads and different input voltages. So at the top you have a selection of TECs, and like CT means the supplier, HP is a different supplier. There's a typical 545 watt eBay one, and so on. So you select your TEC. Then you have the number of them that's in parallel. Now that's physically next to each other, not electrically in parallel. Well, they are electrically in parallel as well, but that's what's implied by that. Then you can select the percentage of input voltage. Down here we have the Qmax, which is the maximum amount of heat moved, or cooling if you like. Umax, which is the voltage. DTmax, which is the maximum temperature difference between the hot and the cold side while moving nothing. Imax, which is max amps. And then we have the voltage at the percentage. Now that only updates once you change this. And then you've got the heat load you can apply to the cold side, and it tells you what the maximum heat load you can move for the current input voltage. So you need to apply less than that, and it will calculate these values down here. Now we have the hot side temperature, and 26.85 is 300 Kelvin. Normally TECs are rated at 25 degrees, 27/26.85 or 300 Kelvin or 50 degrees. Now that is important because that does affect the performance of the TEC. Oops, 500 degrees here, right. So let's just jack those up. And down here we have the heat moved, which is your CPU or GPU or whatever your heat load. This is the electricity used to move it. That is the watts, so you've got the amps and the volts, which equals the watts. We have the total heat load to be cooled, which is the sum of these two. So that's essentially what you need to cool on the hot side. So just over 1,000 watts needs to be cooled by your water cooling, your fan, whatever you want to use. And this is your co-op or efficiency, which we're going to do a video on that, and currently it's 0.6293, which you could say is 63% efficient. Hot side temperature, which is 50 degrees, and the delta, so that is the a reduction in temperature from the hot side to the cold side, which is 9.51, and the cold side temperature, which is currently 40.49. And of course we can increase those, we can reduce the load, and we can change all of these. Now over here we have some graphs. What's moved is constant. What's moved is constant. What's used to move it, and which is this here. So this is electricity used. This is your heat moved, and this is the combination, which is the total heat load. Up here we have something far more interesting, which is the hot side temperature and the cold side temperature and the co-op. So if we reduce the input voltage to 50%, we're going to move that line to here. And that's the co-op on the right hand side, temperatures on the left, percentage of inputs along the bottom, and as you can see co-op's almost 1, which is 100% if you're into efficiency, but it's technically co-op. We're going to cover that later. So that is the TEC calculator. Now we need to remember that the TEC calculator is based on mathematical equations, not tested TECs. So one would expect a very expensive TEC to potentially perform better than these numbers, and a very cheap one to potentially perform worse than these numbers. We need to remember that this is only in relation to the TEC itself. Now, in every situation you will apply a heatsink of some description to the hot side and some kind of heat spreader and heat load to the cold side. Now, both of those devices will have thermal resistance or thermal losses, so your performance will always be significantly worse than the calculator. Well, not significantly worse. It does depend, of course, on whether or not you're using a very poor heat spreader or very poor water block or air cooling to cool it. Then that your performance will be much worse than if you were using a very high quality cooling system. But that's the TEC calculator. It's fun to play with. I commonly pull it out to answer people's questions and just get a feel for possible solutions to problems, especially when it comes to increasing the number of TECs and then reducing the number of volts to it to see if we can increase efficiency. No, I actually can't remember what the numbers were before, but that probably has increased the efficiency greatly. So I hope you've enjoyed that one. You can get this from the store. The store you can access from ultrasonic2.com, where you can access the Facebook page, this YouTube channel. We've got the forum going, and obviously the shop. Now, this is cheap. Well, that's because it's free. But you can get it from the store for free. Hopefully you'll have fun. Alright guys, thank you very much. Bye bye.